welcome everyone. Now, I would like to uh, throw open the floor for the panel discussion. Uh, my first question would be like, what are the manufacturing bottlenecks are most limiting EV skills today? Batteries, semiconductors, or skilled labors, or something else? So, any one of you can answer those questions.
Would anyone like to go, Arvind?
Sure, sir. I was waiting to hear from you, but
No, go ahead.
yeah.
I'll talk after you.
Yeah. I mean, for us, the supply chain is a challenge, and it is because it is not just a pure supply chain. It transcends boundaries, it transcends borders, and of late it is being dictated by political strategy. I mean, we all saw what happened with the whole rare earth magnets. That froze production for a lot of our clients, which impacted us. So what we are trying to do is, it's very important for us to have multiple sources uh, of all our components, and the biggest one of them is going to be the cells. The cells, we as in the government did provide incentives and tried to sort of kickstart that process within our country, but it's been close to, I think, 4 or 5 years now, and it has not taken off in the way that we would have wanted for our industry to really uh, reduce its dependence on the global supply chain. And here I'm specifically saying China, because that relationship is very important when it comes to the whole EV sector. But there are sort of green shoots. People are trying to build factories, build gigafactories even. But I would go back to what Mr. Ramachandra said, that in the long term we have to get more out of what we already have. I would like everyone to hear, think about your last 5 or 10 phones, and think about where the battery is right now, and most likely you would have the answer that it's sort of in some drawer, and that could actually at a volume be so valuable for our whole country, in terms of whether it's used in some other form, or it's used in recycling, because it would give birth to new batteries. And this reverse logistics is what something we have to really solve. And yeah, I mean, those are some of the thoughts that I have when you mentioned this.
Yeah, Arvind, I would echo what Arvind is saying. I would say that the two constraints on manufacturing are supply chain vulnerabilities. Um, we are not sure we'd get the material at the right time, and we are very China dependent. And the second issue is manufacturing technology. It's not trained manpower. This is not manpower intensive. Making batteries or e-mobility is not manpower intensive. So you require a few trained manpower, you require somewhat skilled manpower, which is possible to generate in this country. That's not a challenge. They can train people pretty quickly. But the acts, for example, if you want a welding machine, you want to set up that line with the robotics and everything, I mean, you're pretty much dependent on a Chinese supplier. We haven't developed that capability. And I know the challenges that many are facing. The line doesn't perform, the robot stops, and all the software is in Chinese, and you've got to call them up and they won't respond. So we have many issues. Many of them are really struggling, really struggling there. So I think I don't have a short answer to it. I don't have a solution to it, let us say, not an answer. But I think a lot of people have to put their heads together to see how they can build up that capability very quickly. But Arvind and others, I'd say, there's nothing to actually inspire you to do something than the absolute threat of not getting there. The very fact that you have a sword hanging over your head, or that you've got to do it, will force you to find out some way. So I'm hopeful that people will find some way. Very vague answer.
Mr. Gurusharan, would you like to add something to it?
Sure. Thank you very much, and thank you to Mr. Ramchandra and Mr. Arvind for their views. I think if you look at the Indian ecosystem, there is a very open recognition that we have a lot of catching up to do. If you see the ICE ecosystem, we are now the third largest market in the world. But when you look at the EV ecosystem, we definitely have a lot of catching up to do. And government has been focusing both on incentivizing demand as well as creating supply chains. So you have a phase manufacturing program which looks at encouraging localization of content in India. Currently, of course, the biggest bottleneck is the cells because we don't have access to rare earth elements, and we will need to engage in strategic partnerships to access them, either long-term engagements or some other arrangements. Power electronics is another challenge because of our excessive reliance on semiconductors. And I think the third is scale, because today, if you see in terms of overall penetration, we are just at about 6 or 7%. So I think till this industry does not scale, we will not be able to create a very robust ecosystem and supply chain infrastructure within the country. So I think the steps being taken are in the right direction. The challenges are quite clearly identified. People are quite aware of what we need to focus on, and I think it's a matter of time, investment, and resources that will then finally see us through with a viable solution for this.
Thank you so much for your valuable response, sir. And now the next question is, how are OEMs balancing vertical integration versus supplier partnerships in the EV production? Sir, would you like to add, Mr. Gurusharan?
So, when you look at an EV context, if you see the EV value chain, the number of components as compared to a ICE vehicle is significantly lower, which is why the traditional approach to car manufacturing has always been that a company, traditional, engineering company, be it Toyota, be it Nissan, be it Honda, Maruti, they've all focused on developing the powertrain and some parts of the sheet metal, etc. Otherwise, most of the part of the vehicle has been outsourced. The audio, the seating, the braking, the steering, the suspension, almost everything has been outsourced, and car companies have been specialized at integrating all these together. Going forward, I think because EVs create a very different disruption where the car is not going to return to you as frequently to provide you a recurring source of revenue. You need to ensure that customer lifetime value is safeguarded, because as a business, you also need to be viable. And to do that, you're looking at vertical integration in terms of seeing how much along the value chain can I move. So I think the first very obvious step is that each company is trying to look at backward integration into the battery manufacturing ecosystem. I think Mr. Ramchandra spoke about OEM partnerships. They're looking at forward integration into the charging infrastructure, because charging is one source of recurring revenue for any business. And the third, of course, is software. So today, I think software is the heart and brain of any electric vehicle. And if you see the recent Mahindra, the Tata vehicles, and of course all the international makes, I think they have a very high emphasis on software content. So I think OEMs are trying to own this software development so that the value content that is contained internally within the company, within one business, is maximized, and of course, some future sources of lifetime revenue is also ensured.
Okay, thank you, sir. Mr. Ramchandra, sir, would you like to add something to it?
Yeah, I think to Mr. Gurusharan's point, the traditional automotive manufacturing model has been to concentrate on design, branding and marketing, and assembly. I'm putting it crudely. Even the powertrain that Mr. Gurusharan talked about, many companies would actually, you just buy the powertrain from somebody else, you just buy the engine from someone else and still assemble a car. And that worked. And I said that there was a recurring stream of revenue from service and parts that you sold. Now, you wouldn't be able to sell as many parts. You definitely are not going to be able to sell as many parts, and you definitely are not going to be able to get a stream of revenue from recurring service. So what would be important for them is, and they see components like the battery, which is sometimes 40% or more of the value of the overall vehicle, as being core, not being non-core. And they'd like to insource it. Now, when they insource it, some of them, like Ather, they do actually the assembly of the battery, or Ola, they assemble the battery in-house. Hero also, I believe, wants to do that. But I would think that assembly is not a very critical operation, assembly of the battery. What is critical to them is, as Gurusharan pointed out, the software. So they got to own the software for two reasons. One is so that they get very good performance, and two, they get constant feedback for continuous improvement. If they can't get that, mind you, they'll still outsource seats, steering, brakes, under chassis, suspension. They will outsource car interiors, everything. That's not going to go away, lights and whatnot. But what is going to change is the fact that they have this electric powertrain, which is completely different, which doesn't afford opportunities for recurring service. And if they want to do anything, if they want to actually have a stream of revenue and be profitable, and also ensure that their brand remains protected, they can only do that through continuous improvements, upgrades, and things like that. And today it is possible on these cars. You can just download and upgrade of the software on the air. So I think that is the one thing that they would actually seek to own, in my opinion.
Thank you so much for pointing out this point. Mr. Arvind, would you like to add something to it?
Sure, not much to add after that, but yeah. So again, I agree that the experience is now more software driven, and you can see that in the kind of ads that keep coming for the newer vehicles. We also sort of flip that in the sense that when we go and work with an OEM, we basically tell them to design a scooter or a vehicle that works with our solution. So rather than build trying to fit our battery into their design, we are telling people to make a vehicle that fits this battery dimension and this battery sort of performance, weight, and everything. That gives interoperability, and that's how we sort of look at it slightly differently. And the sort of proof in the pudding for us is the retrofit market. So we are basically able to tap the huge retrofit market, and like the other panelists said, powertrain is an important piece of that. But if you have a powertrain and if you have the battery, you can actually very easily transform or retrofit an ICE vehicle to an EV, and that tells you a lot. In fact, one of the biggest markets that we are seeing emerge is the EVs, the fixed battery EVs that are closer to end of life of their fixed battery, like 2 to 3 years. And now the person who's owning that, and you have to look at the profile of that person in terms of most likely might be a delivery person, most likely not many B2C customers. They face a huge amount of huge cash outlay in terms of changing their battery. So we are seeing a huge acceptance in terms of them shifting their preference towards getting that fixed battery out and putting a swappable solution in, so that they never have to face this problem again. So yeah, I mean, I think it's still evolving. There is going to be space for every solution going forward, but I think it's still evolving.
Thank you so much, sir. My next question is, are the batteries also impacting, I mean, are they recyclable, and does it also harmful for the climate? Because there were some reports that even the batteries are harmful for the climate.
I'll take a shot at it because I think Mr. Ramachandran had already answered that. The thing is that we are sort of witnessing technologies in hydrometallurgy which give us 95 to close to 97 98% of the material that has gone into the batteries. That is uh, that is remarkable in itself. But if you keep a tab on what's going on in the global markets, you would see that there's a shift towards LFP, and that might actually change. Those are not really those are more of second use batteries because they have long cycle lives, but they don't have the more expensive cobalt and nickel sort of composition. So those batteries will not give a huge business case for recycling, but will still have to sort of make sure that they are not disposed of. So that those are two different decisions in terms of technology and in terms of incentives for people to not dispose them off in a sort of irresponsible manner.
Okay, thank you so much, sir. Mr. Gurucharan, would you like to add something to it?
So I think there are two big signs that are showing that recycling is going to become an integral part of this ecosystem. The first, of course, is extended producer responsibility guidelines, where people are talking about ensuring that you are responsible for the environmental footprint of the battery throughout its life cycle, all the way up to reuse, which is circularity. And the second is the battery passport, where you are looking at uh, uh, a tabulation or a sourcing history of where the raw material has been sourced from, whether there's any conflict minerals involved, how much of what has been the usage of the vehicle, how has the battery performed, and everything. So uh, I think the regulation system is going to drive the recycling ecosystem, and I think the realization is quite clear that if we look at rare earth minerals, in spite of the limited geographies that control them, the fact also remains that we don't have an endless supply of these minerals. So, in case we need to make electric mobility sustainable, there has to be recycling that is factored into this ecosystem right from the design stage. So if I run a parallel to the ice industry, I think in the ice industry for the first, it's over 100 years old now, but for the first 30 or 40 years, the focus was only on improvement of performance, dynamics, comfort, etc. I think recycling is something that nobody really actively focused on. It's only off late when people are having when I think focus towards the climate is increasing, when Paris Agreement is becoming very topical. Forums like Davos are becoming more regular. I think it is at these forums where country leaders are now talking about the impact that businesses are having on economies and the need to grow businesses responsibly. So I think the extended producer responsibility, the emission footprint responsibility, and the battery passport. I think these put together will make sure that you have a very robust ecosystem, and recycling will become integral. Of course, the challenges that Mr. Arvind mentioned are paramount because in terms of chemistry, there's a lot of evolution happening. Earlier, we were working only on LFP, NMC. Now you have LMFP and hybrid chemistry. There's a lot of talk happening on anode materials. There is solid state that is coming out. So we don't really know because recycling technology also is developed based on form factor and chemistry. Now, because that context itself is changing. It's like you're preparing for an exam and the syllabus is changing every 6 months to 8 months. So trying to keep up with that is very difficult. The second is that there's also new chemistries. I mean, there is what we know, and then there is also what is being developed. So you have things like silicon anodes, you have vanadium flow. So you have a lot of other battery chemistries that are looking promising because we really don't know which is the most promising chemistry. And One very big insight into this is that very recently China has now banned export of technology IP for any battery chemistry that delivers over 300 watt hour per kg energy density. And I think moving forward, energy density will be the biggest differentiator because the more dense the battery, the smaller the size, the more powerful the pack. It's like that dynamo battery that you have. So I think that's what's going to play a very big role moving forward.
Thank you so much, sir. Mr. Ramachandran, would you like to add something to it?
No, I think Gurusharan has covered everything. There is this huge mandate. In the government, I work very closely. I keep drafting letters on, you know, EPR, extended producer responsibility, and how the industry can work with the government to ensure that these are fulfilled. I work almost constantly on that. One of the challenges that we have is that despite all the good intentions, that we have an EPR in place, we have the battery passport, BPAN, we have other initiatives in place. One of the things is that we definitely need to see how we can make it viable, how we can make recycling viable. So one of the suggestions that I gave some time back is to actually have a concessional. See, the biggest cost is cost of sourcing the material and power. Power is the other big cost. And I said, for the recycling industry, we shouldn't charge the same rates of electricity or same charge of power. So I think if they were to output X of primary metal recovered from batteries or whatever, you would actually give them a subsidy. And that would be a very targeted subsidy and very meaningful subsidy, in my opinion. That could be a good policy move. The other thing is that we are also permitting through laxity, we are permitting export of black mass today. I mean, it's happening surreptitiously, it is happening with the knowledge of some people, and that's a terrible loss to us. So I think there is something that needs to be done over there, but I shall not talk more about it. Thank you.
Thank you so much, sir. Sir, there is one question for you. Like the government of India is now working on 2G ethanol, which is the second generation ethanol. So how do you see this push? Because this is again where the ICE takes a center stage. Are we looking at balanced EV ICE market moving on?
So there will be markets that will be slower to adopt electric mobility. As I mentioned, like there are segments of the market, and Arvind has also identified it very well. There is e-buses, there is delivery vehicles, there is cargo vehicles, intra-city operation, and there is also perimeter vehicles. So this would be the first to adopt. The next stage would be people with high mileage on their two-wheelers and things like that who would take it on. And then it would gradually spread. So in the meantime, you require a solution to reduce emissions for, say, tractors, trucks, and things like that. And therefore, in my opinion, we should also have that ethanol thing going. I mean, if it actually um, reduces emissions, so be it. I think it's a good thing because you're not going to get e-mobility happening across the board in, say, 2 or 3 years. It's not going to happen, or even 5 years or so. It's going to take time. You require bridge technologies. So I might use this if I were to use a word, I might call it a bridge technology, this ethanol mix or blend.
Okay. Okay. Thank you so much, sir. Mr. Gurusharan, would you like to add something to this?
No, I think Mr. Ramchandra has covered the whole thing. But if you look at the ethanol conversation, I think its story started right from 2004, 2005, where we spoke about because we have to accept the fact that over 80% of the crude that we use in India is imported. We are heavily reliant on crude, and the only way to reduce it is either reduce consumption, divert consumption by going to e-mobility, or blend consumption by adding something that you have abundant of. So we have a lot of sugarcane. I think we are the second or third largest producer of sugarcane in the world. Ethanol is a byproduct of that. It creates incremental revenue opportunities for farmers, which is a very big let's say, employment base in India. And then going back to in terms of roadmap, we started with E5, we then went to E10, then we moved to E20, and then very shortly we'll also have E30 coming in. And I think in this journey, India is looking at Brazil as a very big teacher or as a role model, where you also have ethanol 100 or up to ethanol 85 vehicles that are operating as commercial as regular vehicles. But I think the biggest difference that you can see in markets like Brazil, which we are trying to emulate, and India, is the information transparency. So today, when I go to a filling station, I don't get any information on what sort of blend is being put into my tank. So it is called super. So I know that it has an octane number over 95, but I don't know what is the blend content. Whereas when you look at a market like, let's say, the US or Brazil, you will have the pumps which have specific nozzles dispensing E30, E85, E100. So I think the transparency and the customer awareness is much higher. In terms of technology, if you see vehicles, so today there's a lot of conversation happening around flex fuel, and flex fuel basically will allow you to, I mean, the engine is compatible to ethanol blending right from 20% all the way to 100%. And the way people make the choice of filling is depending on the rate of the blended ethanol on that particular day. The next, I think, concern which why there is so much debate around ethanol is that it was always felt that there will be some price benefit that will be passed on to consumer because of this blending. Unfortunately, the prices have remained where they are. You have a blend, you don't have clear awareness about what that blend is going to impact your vehicle performance in case it is not ethanol 20 compliant. And the government is pushing a mandate in terms of trying to accelerate adoption. So I think that is some of the challenges. But Mr. Ramchandra used a very good terminology, bridge technology. So in the pursuit towards decarbonization, I think a lot of technologies will have a role to play. You will have hybrids, you will have electric, you will have hydrogen, and you will also have ethanol.
Thank you, sir. But sir, there is one question for you. How safe are the thermal management systems in the EV? Are there any manufacturing norms while putting these systems in the vehicles?
So, I think the good part about India is we are a regulation-driven business environment. I think before liberalization, I think the biggest the inhibitor to India's progress was the abundance of government control. And fortunately, that mindset has we have not gone away from. We also have a very good source of talent and knowledge, which allows us to understand each technical issue. So I think in 2020, 21, when we had a lot of electric vehicle fires, there were very informed individuals from IIT, ARI, etc., who sat together and who prepared guidelines in terms of AIS 138 and AIS 036, so that they gave very clear guidelines in terms of what is the impact of how to mitigate the impact of a thermal runaway. Because a thermal runaway is a reality in a EV battery. In fact, even today, ICE vehicles also catch fire. Maybe the intensity or the frequency or the reporting of these incidents is less severe, but they also catch fire because gasoline is a very potent source. With batteries, I think uh, today the biggest limitation that we face is because this technology has been developed towards the West or towards Asia, I mean, with China as an example, it is not yet India centric. So we have extreme summer, and in some parts we have extreme winter. So I think that technology is taking time to adapt to Indian conditions. We will learn as we go along, but in terms of regulation, there's a fairly robust system in terms of how the thermal management function should, how the system should function, what are the advanced warnings that it should give, whether it should have a fuse, whether it should have an emergency release, button. So I think all efforts are being to made to ensure that in the unfortunate event of a thermal incident, the warning time is much longer, so that you are safe in those incidents. Because a battery fire is like a bomb. I mean, it's very just a few seconds between the time it is first ignited to its final completion of combustion. So I think these efforts are making sure that first of all it does not go to the full extent of damage that it can create, and in the unfortunate incident that all safety checks fail, the time that it takes to take that is fairly elongated. So it gives you time to react and respond.
How safe are the thermal management systems in the EV? And are there any manufacturing norms while putting these systems in the vehicles?
Yeah, I'm afraid I'm I'm more of a business and strategy guy, and that question seems to be a bit too technical for me. So yeah, I'll skip that one with your permission.
No problem, sir. So the next question is, what manufacturing innovations are actually delivering cost reductions?
So yeah, I mean, manufacturing wise, more automation, less people centric. It's still more on the sourcing and supply chain side that the bigger efficiencies lie. In terms of manufacturing, and I'm talking specifically from a company like Sun Mobility point of view, because we don't manufacture full vehicles, we manufacture battery packs, and there the level of automation has reached for us at a level where we are sort of spitting out one battery pack a minute, and then it's from a semi-automated line. So I think as far as the current demand scenario is asking for it, we are more than covered with the capacity. It's the other bigger rocks that we have to attack. I would invite the other panelists to contribute a little bit more on that, please.
Thank you so much, sir. Uh, Mr. Ramakrishnan, would you like to add something to?
All that automation is not so much for reduction of labor costs, because labor cost is not a huge component, of the battery cost. What it does is it improves yield. You have that is one thing that you need to do, which means that if you have, let's say, 5% of cells being rejected because they don't meet the grade, or when you grade them, sort them, and things like that, if you have got some rejections, that's a cost that you're actually going to bear, and that's there on the battery pack and on the EV ultimately. You also get during manufacturing, if you have poor productivity, what you're doing is it's not so much the people productivity, but the machine productivity. You see, the machine is a very, very expensive piece of equipment. For a country like India, where capital costs are very high, ensuring high throughput per machine. Let's say you bought a machine for, let's say, 2, 5, 6 crores or whatever, a complete welding line. Making sure that you get that throughput or the design throughput is very important to ensuring that your cost per battery is actually acceptable. Otherwise, that capital cost and the interest on it is also sitting on that battery. The third part is the quality. If you have poor quality, putting it rather vaguely, the cost of poor quality actually is quite high. Because it's very difficult to detect this. So if the welds are weak and they would come off during service because of vibration or anything like that, this would be very difficult unless you have a very robust quality assurance process. So today, I think one of the things the industry must do is to spend a lot of time on developing appropriate QA measures for manufacturing or assembly of battery packs. That's very critical. And also cells, if they get into cell manufacturing. So I would put my stress on these three things, that is yield, productivity, and quality, if I wanted to take manufacturing of batteries to the next level.
Thank you so much, sir. Mr. Gurusharan, would you like to add something to it?
So I think automation is, I mean, it's something that a business naturally adopts because you want to maximize your throughput. The more efficient your resources are, the more value that you are drawing out of them. And I think in addition to that, the tangible benefits that it delivers, of course, the first is accuracy. So accuracy for processes like welding, assembly, etc. I think a machine doesn't tire. It can be taught and it is repetitively consistent. The second, I think, is consistency. So, in terms of the output, when you have a lot of automation on the line, you always ensure that the output is quite consistent. The third, I think, is um inventory, because I think inventory has a very big role to play in your overall production cost. So you'll see a lot of lines being fed by robots, where the inventory is being brought in just at a 1 or a 3 day advance notification, so that you don't have, I mean, you don't. um have a lot of inventory cost that is feeding into the line of production. The next, of course, is uh, your uh, your supply chain ecosystem itself, where you are integrating your production system with your suppliers to ensure that the availability of the child parts that are going to feed into your line are completely aligned to your main production line. And I think the last is possibly labor, because I think today businesses are looking at minimizing the impact, or let's say the dependence on labor for critical as well as non-critical activities. So, one very simple example: if you try to call any call center today, 9 out of 10 times you will first be met by a robot or a bot, and only after that has not been able to address your queries, you will then be passed on to a human contact. And you'll be surprised to know this, and possibly India is also headed this way, that in certain advanced countries, establishments like banks, etc., they actually charge you a fee to interact with an individual, because there is an entire automation process available. But if you are going to go and approach an individual for an intervention, you will have to pay a charge for that. So I think you will see that reality coming in very soon in India. Uh, Another very interesting observation, and you can see it around you. You go to any McDonald's, any Pizza Hut, any this, the ordering system, the point of order has now been turned as a screen facing you. So the customer himself orders, and then the staff is just ensuring that they're working on the kitchen and the delivery activity.
Thank you so much, sir. Sir, there is a question for you again. There is a policy uncertainty like subsidies, frame change frequently. State level policies are inconsistent. So, how do you EV manufacturers deal with this?
So, I think this question is very, very relevant, but there's no direct answer for it, because policy uncertainty is a part of the ecosystem. So far, FAME 1, FAME 2, and now the PME drive, there has always been uncertainty in terms of how much is the demand incentive, how long will it be extended, what sort of vehicle classes will it cover. So typically, the industry requirement is that if you are going to develop any product, and you are also keeping incentive mechanism in horizon, the development cycle and the scheme cycle, there should be alignment between that. It shouldn't be sporadic. You can't say that, okay, I have run out of my budget for electric three-wheelers in PME drive, so I will not disburse it anymore. So I think there has to be more transparency. There has to be a longer term focus, and of course, states is another challenge, because today center and state operates quite independently, and I think states need to synergize more closely with what the center is doing. Thankfully, while there is talk that PM E-Drive may possibly not be extended beyond March 26, a lot of states are now drafting policies which are extending right up from 25 to 2030. So there is a possibility that states will continue this momentum, but the center, we are still not very certain on what will happen beyond March 26.
Thank you so much, sir. Mr. Arvind, would you like to add something to it?
Yeah, sure. So, it is definitely a reality that policy and policy advocacy is going hand in hand in terms of what we are trying to achieve, not just as a state, I mean, as a nation, as a group of companies also. But from a business and strategy point of view, but it's my strong belief that business models that ultimately will succeed are those which are not dependent on policy support in the long term, and also not dependent on VC funding or PE funding, continuous VC and PE funding. The unit economics has to start making sense at scale sooner than later. This is going to be an imperative for the firms that actually come out on the winning side on these on all matters actually. Regardless, there are a lot of imbalances which multiple agencies have to sort of interact with the government, negotiate with them, educate them, understand the constraints over there, and pick those battles which are sort of more obvious. For example, when we sell a product to our customers, they pay 5% GST. Meanwhile, on the inputs, we have to pay 18% of GST, which means we are we are building huge working capital of receivables on GST, and then that is easily solvable because anybody would be able to see the sort of logic of why that mismatch should not exist. Second example would be right now, because I'm sitting in Bangalore. I'm sort of talking about those problems for EV testing facilities. You either have to rely on a Chennai or you have to rely on a Pune. So having that conversation with the government of Karnataka is something which we would focus our energy on rather than uh, rather than focus our energy on trying to understand what are the B2C side incentives or money being handed out by the government. So that is my 2 cents on that.
Thank you so much, sir. Mr. Ramchandra, would you like to add something?
So I'll be brief over here because they covered quite a bit of it. But I think what's it that we're trying to do? So when we look at policy advocacy, if you want to promote e-mobility, you want to do it because you want to save foreign exchange. You don't want to replace one problem with another. So instead of importing oil, if you start importing lithium or cells or electronics, you're not solved anything. So that's a bit of a challenge. We cannot have a situation where that continues. So if you're not solving the problem, you're solving, let's say you're going into e-mobility for two things. One is to solve the emissions issue, and the other is to solve your foreign exchange issue. You just can't pay for it. So you've got to design your policy suitably. So I think sometimes maybe some of the policies were designed a bit hastily. So a lot of manufacturers taking undue advantage of it and just claiming subsidies without actually achieving the end objective, which is that of localization. They got penalized for it and all that, but then a lot of mess happened. The second thing that happens is if policies are designed poorly, and we can see the battery PLI and ACC. And net, what happened is that we hardly had 1 gigawatt hour of capacity coming up. When you put conditions that are not realistic, you will not actually spur innovation. You will not get the thing. So what you need is you need innovation in terms of research. So that Anusandhan Research Foundation thing, which is their 1 lakh crores that they're giving out. So you require new chemistries to come up. You need investments over there. You need semiconductors. You need stuff like that. So I think policy advocacy must look at what is it that you're trying to achieve, and therefore direct your policies and design them suitably so that the right things take place in industry. And there I think there is need for some more improvement. I'll put it there.
Thank you so much, sir. There's one question for you. What's one emerging technology or trend that deserves more attention than it's getting?
I would see there are many that are promising, but it's not that they have actually um, sort of been commercialized. the three to my mind are, and I'm not looking at flow batteries, which Gurushan talked about, which is more for long duration energy storage. But if you're looking at the context of e-mobility, I'd possibly say sodium ion, then metal air, and hydrogen. And of these three, at the moment, the one that seems to be closer to commercialization seems to be hydrogen. In hydrogen, again, you have the hydrogen IC engine and you have the hydrogen proton exchange membrane cell, where you would have a fuel cell. And I think a lot of attention needs to go over there because that's got great possibilities for heavy vehicles and for railways. I mean, we can go deeper into it, but I'll stop here. That's my short answer.
Okay, thank you so much, sir. Mr. Gurusharan, would you like to add something to it?
I think Mr. Ramchandra has covered, I think it will be batteries in terms of chemistry and form factor. The second would be software. And the third possibly could be maybe user interface, but then that is addressed through software. So I think it will mainly be battery and software.
Okay, thank you so much. And Mr. Arvind, would you like to add something to it?
Yeah, one sort of emerging field I'm really hopeful about is the whole concept of a digital energy grid, which is sort of backed by the sort of dual side chargers and mechanisms so that everybody can participate in the grid. There is flow back to the grid. People can have those contracts, those identifiers. For example, if you look at there's a very interesting paper by Beacon Protocol. Mr. Nilekani is heading that, and that would be a truly game changer. Imagine a world where you're getting paid for everything, and everything is being tracked in terms of energy. Energy can flow peer to peer, can flow stay, grid to people, people to grid. So that I think is something which excites me.
Thank you so much, sir. With this, now we are at the end of the session. I would personally like to thank every one of the speakers to be present at the webinar, and I would also like to thank all the participants for being in this webinar.